This video is a geometric interpretation of the difference of two squares. We know what the algebraic formula is for the difference of two squares, x squared minus y squared, a squared minus b squared. But when we look at that geometrically, what we want to try and find out is if we can back that formula up. Also, you may want to check out this prior video which I made on completing squares, so that you can understand about factorization and expansion, which may be a useful little primer before we go any further. Recall the factorization difference of two squares has the form a squared minus b squared, c squared minus d squared, x squared minus y squared, or in this case x squared minus 1/2 squared. Where on the left and on the right we have two terms, both of which are squares, and in the middle we have a subtraction sign, which gives us the difference, hence difference of two squares. Recall, when expanding a factorized quadratic, we follow the acronym FOIL. F is first, O is outer, I is inner, L is last. Take the example x plus 7 into x minus 4. If we look at the respective first terms and take the product, we get x times x, which gives us x squared. Take the product of the respective outer terms, we get minus 4 times x minus 4x. The product of the respective inner terms, plus 7 times x plus 7x. The product of the respective last terms, plus 7 minus 4 minus 28. So this expands to x squared plus 3x minus 28. The minus 4x and the plus 7x are brought together. But what we need with the difference of two squares is not to have anything here for the x term. So we need the plus 7 and the minus 4 to cancel out, but they don't. So we need the same value with the opposite sign. So let's look at that now. Here's an example of the same value with the opposite sign. X plus 7 into x minus 7. Multiplying the first terms, x squared. Multiplying the outer terms, minus 7x, multiplying the inner terms, plus 7x, and the last two terms, minus 49. So this expands to x squared plus 0x minus 49, because the minus 7x and the plus 7x cancel to give 0. So now we have a difference of two squares. Visualization of the difference between two squares. X squared minus y squared, as we've seen, equals x minus y into x plus y. Now, let's have a look at this large pale blue square and the small dark blue square. If we denote the side length of the large square as x and the side length of the small square as y, then x squared minus y squared is just the difference in area of the larger square to the smaller square. We can see that as being the areas that we've overlaid here in pink. So we simply need to find out what these areas are. Let's investigate. Now we want to reach the conclusion showing that x squared minus y squared is the difference of two squares. But looking at that diagram, we can see that the difference of the two squares is clearly that area of light blue which is not covered by the dark blue. So if we sum up those two rectangles and that square, we should get x squared minus y squared. So let's start with the width of that right hand side rectangle. Well, that's clearly the side length of the larger square minus the side length of the smaller square, x minus y. And by symmetry, that width of that rectangle, the left-hand side rectangle, must be the same. Now let's work out the width of that right-hand side rectangle. Well, that must be the length of the side length of the larger square, x, minus that little dimension that we found by symmetry before. So x minus bracket, x minus y, close bracket, which gives us y. so that length is y. Now, the area of that rectangle is length by breadth, which is x minus y times y, which gives us xy minus y squared. Because we have two of them, that gives us 2xy minus 2y squared. Last of all, we need to work out the area of that square. Well, the dimension is x minus y, by x minus y. So we need to multiply x minus y by itself, which gives us x squared minus 2xy plus y squared. If we add that to what we had before, which was 2xy minus 2y squared, the 2xy and the minus 2xy cancel out, and we have x squared minus y squared. So indeed, those light blue areas sum to x squared minus y squared. Thanks very much for watching. I hope that was interesting as well as possibly helpful. I wanted to just show the visual approach that we could use to back up the algebra. If you liked, feel free to like and subscribe so that you can see when more videos come out. Thanks very much.